Hello everyone, welcome to our class. Today in this class we are going to discuss about ray diagrams for concave and convex mirrors. So let's see what are the ray diagrams for concave mirror as well as convex mirror. Here for concave mirror there are 4 ray diagrams are possible. How many? There are 4 ray diagrams are possible for concave mirror. Let's see what are the 4 ray diagrams for concave mirror, where these ray diagrams are useful in a further classes to us. Let's see. The first thing is if incident ray is parallel to the principal axis. So the first case is the incident ray is parallel to the principal axis. If incident ray is parallel to the principal axis. Parallel to the principal axis. So this is the first case for ray diagrams for concave mirror. So ray diagrams for concave mirror. Let's see. So first of all, draw the concave mirror. We know that already we have discussed in last class. Concave mirror having reflecting surface inside, coated surface is outside, and this is a coated surface, and this thing is this side is reflecting surface. And we know that midpoint of the mirror is pole and center. So which line is passing from pole and center? Which line is passing from pole and center? That is principal axis. This is our principal axis. And put the point, we know that that is focal length. That is focal point. So pole point, focal point and the center of curvature. Now our case is if incident ray is parallel to the principal axis. If incident ray is parallel to the principal axis. Imagine one incident ray is falling on concave surface. It is lies parallel to the water principal axis. After striking mirror surface, the reflected ray should be bounced back. The reflected ray should passing from focus. So what is the case? If the incident ray is parallel to the principal axis, the reflected ray is passing from pole. So after reflection, the reflected ray is passing from pole. This is a case 1. So the first possibility of ray diagrams on concave mirror, if incident ray is parallel to the principal axis, reflected ray is passing from focus. And the second one is second case is case 2. If incident ray is passing from focus. So first case parallel to the principal axis, and the second case is if incident ray is passing from focal point, focus. If incident ray is passing from what? Focus. Let's see. So quoting is very important, or else you lose the marks in examination. Principal axis, pole, focus and center of curvature. Now what is the case is incident ray is passing from focus. Now let's draw the incident ray is passing from focus and strikes a mirror surface. Incident ray is passing from focus and strikes the mirror surface. What is our reflection now? From where reflection ray is passing out? Let's see. After reflection, the reflected ray should be parallel to the principal axis. It's exactly opposite to the first case. In first case, if incident ray is parallel to the principal axis, reflected ray is passing from focus. But in this case, if incident ray is passing from focus, reflected ray is exactly parallel to the principal axis. That is our second case. And let's see here third ray diagram for concave mirror. What? Third ray diagram for concave mirror. Let's take case 3. So expect what is our case 3. The first case is if incident ray is parallel to the principal axis, reflected ray is passing from focus. Second case is if instant ray is passing from focus, reflection is parallel to the principal axis. And third one is, what is our choice we are having here? The next one is, maybe the instant ray is passing from center. Maybe the instant ray is passing from center of curvature. Case 3 is nothing but what? Instant ray is from center of curvature. Instant ray is from center of curvature. Let's see about if the instant rays may be passing from center of curvature. What about reflection? Draw the concave mirror. Pole, focus, center. Now what is our case? If instant ray is passing from center of curvature, let's draw the gray diagram from center, and it strikes at a mirror surface. So instant ray is passing from what? Center, and strikes at a mirror surface. And here the thing is, the reflection ray also allows similar path. Means reflection is taking place from center of curvature, as well as instant ray is also coming from center of curvature. In this case, we are able to see one ray. So actually in remaining cases, reflected ray is different and instant ray is different. I mean, we are able to see the what two are different. I mean, we can recognize instant ray is different and reflected ray is different. But in this case, only we are able to see the what one ray. We are able to see the what one ray only, that is passing from center and moving from center only. If instant ray is coming from center of curvature, reflected ray also passing from center of curvature. And the next case is case 4. So in this case 4, so one more thing we are having, last point is what? P. So focus is completed, center is completed, parallel is completed. And the next one is what? P. If maybe instant ray falls on P point, nothing but pole. So what happens to reflection? Let's see. Draw the concave mirror. Look at points P, F and C. Now the instant ray falls on P. And reflection also start from P only. So these are the 4 cases for concave mirror. It's a very, very important examination pattern, as well as these 4 ray diagrams are useful in image positions also. And our next topic is image positions. In that image positions, we will use these 4 ray diagrams for concave mirror. So once again I am repeating here. So what are the 4 ray diagrams? For concave mirror? The first one is if instant ray is parallel to the principal axis. So first 2 cases are very easy to us. I mean, very easy to remind that. So first ray is instant ray is parallel to the principal axis. Reflection from focus. And the second case is if instant ray is passing from focus. Reflection is parallel to the principal axis. First case is parallel to the principal axis, instant rays and reflection from focus. And second case is if instant ray is coming from focus, reflection is parallel to the principal axis. Third case, reflection and the instant ray allow similar path. So they are chooses similar path. Instant also coming from center, reflection also moving from center. And the last case is if instant ray falls on P. Reflection also passing from P only. These are the 4 cases for concave mirror. Let's see what are the ray diagrams for convex mirror. Now ray diagrams for convex mirror. For convex mirror, so there are 3 ray diagrams are there. How many? 3 ray diagrams are there for convex mirror. Concave mirror 4 ray diagrams. For convex mirror 3 ray diagrams. What are they? The first one is similarly parallel to the principal axis. Second case is passing from F. And the third case is passing from center. Okay sir, both are similar, parallel, passing from F and passing from center of curvature. Just now we have seen from concave mirror also, so they are similar on convex mirror also. So actually here ray diagrams are similar on concave and convex mirror, but concave mirror is a converging mirror, convex mirror is a diverging mirror. I mean their movement, nothing but the passing of instant rays are different on concave and convex. In concave converges, convex diverges. Let's see how to draw ray diagrams for convex mirror. Let's draw the word convex mirror first. So we know that convex mirror having reflected area is outside, coated area is inside. Coated area is what? Inside. Coated area is inside, reflected area is outside. And the last class we have discussed about this. So pole, focus and center. Pole, focus and center. So principal axis. Now reflection is possible this side. Yes, reflection is possible this side. Now imagine one ray is parallel to the principal axis. Which ray? First incident ray is parallel to the principal axis. Just imagine here one incident ray is coming from lighted source. The rays falls on convex mirror. Rays falls on convex mirror. The incident ray is parallel to the principal axis. Parallel to the principal axis. We know that this mirror is diverging mirror, and that is what the reflected ray diverges back. The reflected ray is diverges back. But here, if you are extending these diverged ray, inside, actually this is imaginary path, imaginary path only. So extending inside, which ray we are extending, which ray is diverged back, that ray we are extending inside. It is looking like maybe the ray is coming from focus, and that is what parallel to the principal axis, instant ray is in a concave mirror passing from focus. And here also similarly, if instant ray is parallel to the principal axis, the ray is diverged back. If you are extending the diverged ray inside, just imagine like that, if you are maybe extending the rays inside, so the rays look like what? It's coming from focus. Which ray? Diverged ray is coming from where? Focus. That's just imagination. And the second thing is passing from F. How instant ray is possible passing from F on convex mirror? Why? Because here the focus is lies at the area what coated. Focus is lies coated area side. It is not visible to us. On concave mirror, focus, radius of curvature, center of curvature, these are visible to us. But on convex mirror, we can't able to find the what, we can't able to see the what focus. Why? Because focus is inside the mirror. Focus is inside the mirror, and that is what, how that ray diagram is possible. So passing from focus, how it is possible. Let's see how it is possible. So convex mirror, pole, focus and center. Just imagine reflection is possible. Reflection is possible at this side only. So maybe consider one ray is coming like this. We don't know actually the ray is coming from where. So but the ray is coming like that. But after reflection, after striking this convex surface, it is reflected back. The reflected ray should be parallel to the principal axis, maybe. In this case, if the ray is, one instant ray is coming like this, after reflection, reflected ray is parallel to the principal axis. So what is our observation? If you are extending these incident ray into inside, the instant ray also coming from what? Focus. And that's what I am using, passing from focus here. So our observation is, here the reflected ray is parallel to the principal axis. If reflected ray is parallel to the principal axis on convex mirror, definitely maybe the ray is coming from where? Focus. Understood? So next thing is, in the last 3 ray diagrams I said. So first diagram is about the instant ray is parallel to the principal axis. and reflected ray also passing from focus. And the second thing is, if reflected ray, incident ray is passing from focus, reflected ray also parallel to the principal axis. And third case is, we know that maybe the ray is coming from center of curvature. Maybe the ray is coming from center of curvature. Let's see third case is. Case number 3. Case 3. Convex mirror. Let's draw the convex mirror. Pole, focus, center. So imagine similarly one ray is coming, like how we are taken the ray from second ray diagram. Similarly, you can take one ray diagram, but we don't know from where the ray diagram is. So we don't know actually the ray is coming from where. So after reflection only we are deciding the ray is coming from maybe focus or maybe center of curvature. Let's see that one ray is coming like this, but after reflection there is no reflected ray we have found separately. So actually in all cases incident ray is separated, reflected ray is separated, but in this case we are able to see only one ray after reflection also. So how concave mirror shows when the incident ray is passing from center of curvature, reflection also passing from center of curvature, like that. Similarly here, if the ray is coming from center of curvature, reflection also taking place from center of curvature only. So in this case we are able to see only one ray. So but the ray contains two rays, such as reflected ray as well as incident ray. These are the 3 ray diagrams for convex mirror. So once again I am repeating this. So first ray diagram is, first possible ray diagram on convex mirror is, if incident ray is parallel to the principal axis, reflected ray also passing from focus, or else if you are extending the diverged ray inside, the mirror, and the diverged rays may be coming from focus. And the second ray diagram for convex mirror is, if incident ray is coming from focus, the reflected ray is parallel to the principal axis. And third case is, if incident ray is coming from center of curvature, reflection also taking place from center of curvature. And our next topic is image positions. So what are the image positions are possible on concave and convex mirrors? So image positions on concave and convex mirrors. So before explaining this, actually what is image? Let's see what is image first of all. So image, the image is nothing but representation of external form of thing or person is called as image. Representation of external form. For example, consider one object. That object external form is called as what? Image. If, for example, if one object is appeared on mirror, on plane mirror, an object is appeared on plane mirror. So but actually how that object is appeared, we are discussed in previous classes. Here the diverging rays. So when the rays are coming from object, diverges and appears over the mirror surface, that is nothing but image. So image is just able to remind, the definition is nothing but representation of external form of thing or a person or whatever you can consider, which objects are possible to show images, that all those are applicable here. Thing or a person is called as image. Basically images are two types. Two types. They are real images and virtual images. Before explaining these real and virtual images, so probably most of the people get confused. Images and photos are similar, but actually image is a different thing and photo also a different thing. So photo defines as image created by a light falling on a photosensitive surface called photo. So that image only again captured on a photosensitive place by light is called as photo. So photo is a different thing. So presently we are not going to discuss more about photo. Let's come to our topic, images. So how many images we are having? Two types of images, real images as well as what? Virtual images. Let's see what is real image and what is virtual image. What is real image and what is virtual image. Let's see, real image is nothing but which images are forms on screen. Forms on screen. Forms on screen. The real image is only forms on what? Screen. But virtual image appears on mirror. Appears in the mirror. Appears in mirror. Nothing but and our day-to-day experiences. So if you are standing in front of the mirror, it's a plain mirror. So what is the images we are having experience daily? That image is nothing but virtual image. So what are the images maybe we are seeing from a projector or a cinema theater? These all those are the best example for real images. These real images captured by only concave mirror. So concave mirror can show the what? Real images. But what about virtual images? Virtual image can captured by plane mirror, concave mirror and as well as convex mirror. The three mirrors can show the what? Virtual images. But these real images are possible only on concave mirror. Actually these real images defines as the converging rays. The converging rays of light can form the what? Real images. Diverging rays of light can form the what? Virtual images. We can simply define what is real image and what is virtual images. Which image forms on screen? Which images forms on screen? That images are called as real images. Which images are appears in mirror are diverging rays appears in mirror called as what? Virtual images. So these real images are inverted. So these real images are what? Inverted images. Virtual images are erected images. Virtual images are erected images. Real images are what? Inverted images. Virtual images are erected images. Inverted, erected. These are the some differences between what are real images and what are virtual images. And this is the topic about the word images. Once again I am repeating here, representation of external form of thing or a person is called as what? Image. So basically images are two types. What are they? Real images as well as virtual images. Which are forms on screen? Real images. Which are appears in mirror? Virtual images. And real images are captured by concave. Virtual image can appear in mirror, plane mirror, concave mirror as well as convex mirror. But photo is a different thing. So photo is a representation of image, nothing but image created by light. So light can create that image that falling on a photosensitive place. Understood? So that is about photo. And the next topic is image positions for concave and convex mirrors. This is very important in 4 marks types of questions in annual examination. So image positions for concave mirror. So how images forms on concave mirror? How many types of images are forms on concave and convex mirror? So let's see image positions for concave mirror. So actually how many positions are possible on concave mirror? So simply P, F and C. Simply, so we can understand how many ray diagrams, how many image positions are possible on concave mirror. So how many positions are there here? So first of all, P, F, C, we know that. So first position is object at infinity. If you are placing object in front of concave mirror at the infinity of distance, nothing but if we don't know about what is the distance of object from concave mirror, such case we can treat it as object at infinity. So only one thing here, object distance is we don't know what is object distance is not given, object distance is not given. That case is object is at infinity. So from where somewhere else the object is placed, but we don't know the distance, object distance is. So that is the first case, object we are placing at infinity, that is object at infinity. And the second case is, our second position is object placed beyond C. object placed beyond C. After C, you are placing anywhere after C. For example, here the center of radius of curvature is 30 centimeters. Center of curvature is located at 30 centimeters. After 30 centimeters, if you are placing object, that is considered as beyond C, object at beyond C. Understood? And the third case is, and the next position is after C, C is possible. So object at C. So first case is object at infinity, second case is beyond C, and third case is object at C. Exactly. So just example I was given here, 30 centimeters. If you are placing at 30 centimeters, exactly object at C. And the fourth case is object between, after C, here the space is there, but the space we should consider between F and C. So object between F and C, object between F and C. If you are placing object between F and C, that means if you are placing, for example, here center of curvature is at 30 centimeters, then what is focal point? 15 centimeters. After 15, before 30, from 16 to 29, if you are placing anywhere, that position is considered as object between F and C. Got it? And the next position is object at F. Fifth position is what? Object at F. Object at F. And the last position, sixth position, is object between F and P. F and P. If you are placing object here, that is considered as object between P and F. How many positions are possible here on concave mirror? There are 6 types of positions are possible. Let's see once again. Object placing at infinity of distance, and that case object distance is not mentioned, that is considered object at infinity. So second case is object at object beyond C. If you are placing object beyond C. Object at C, if you are placing object at C. Object placing between F and C. Object placing at F. Object placing between P and F. Let's see the what image positions for concave mirror by using that 6 positions. The first position for concave mirror is object at infinity. Object at infinity. Let's draw concave mirror. P, F and C. In this case, we don't know what is object distance. Object distance is not mentioned. So in that case, maybe object placed somewhere else, that all the rays coming from that object are parallel to the principal axis. Take the example sun. From the rays coming from sun, all are what? Parallel to each other. So these parallel rays are striking over the mirror. All the rays are parallel to the principal axis and parallel to each other. We know that if the incident ray is parallel to principal axis, from where reflection is taking place? The reflection is taking place from focus. So these all rays are passing from focus. So all rays are passing from focus. Already just now I explained what is image and what is real image and what is virtual images, which are forms on screen, that is real image, which are appears in mirror, that is called virtual image. See here, where these all reflected rays are intersected, where these all reflected rays are intersected, the converging rays can form image, concave mirror, converging reflected rays can form real image. Here the all converging rays are intersected here, so all the rays are intersected here, then image is formed at F. Here the image is formed at the position of F. Image is formed. What type of image is formed? Maybe is a real image or a virtual image. Let's see. Image formed at F. Image formed at F. It is look like dot, nothing but it's a point sized. So we can't mention the what characters such as what it is a inverted image as erected image, but it is a real image. It's a point size image. Simply we can say point sized image is formed. Point size image is formed. So the first position is for object placing at infinity. The case is always, for example, if object distance is not mentioned to us, and that case blindly you can follow the what all incident rays are what parallel to the principal axis. So if all rays are parallel to the principal axis, reflection is taking place from focus only. So here the image is formed, where at f image is formed point size image is, that is it's a point size image. And the second case is, second position is object beyond C. Object beyond C. Let's draw the one more diagram for concave mirror. P, focus and the center. So I am just consider one candle here as object, so that object is placed beyond C. Now I am just taking two rays to showing the what image positions here. Actually candle have lot of rays, infinity rays are possible around the flame of candle, but I am just taking two rays for showing the what image position. So just imagine the two rays are coming from candle flame. So the first ray is coming from the tip of the flame. That ray is parallel to the principal axis. That ray is parallel to the principal axis. First instant ray is coming from tip of the flame, that is strikes at mirror and reflected back from focus. Reflected back from focus. And second ray is also coming from tip of the object. It is passing from C and strikes the mirror and reflected back from C only. So where these two reflected rays are intersected, we know that that is a image point. Where the two reflected rays are intersected, the converging rays are intersected, that is our image point. Here intersection is done. So image formed between F and C. Image formed, if you are placing screen between F and C, we will get the what? That inverted image. Inverted image is nothing but it's a real image. It is captured on screen. If you are placing screen here, and then that time only we will get the what? Image on screen, or else it is not observable to us. So once again I am repeating here. If you are placing object beyond C, ray is coming parallel to the principal axis, passing from focus, and second ray is coming from center of curvature and moving from center of curvature also. Where that intersection is done, that is our image point. We are taking only two rays, so why not remaining rays? For example, if the ray is take from the what focus, the ray is take from the what P. So you can take any, like the 4 ray diagrams we have discussed. From that 4 ray diagrams, you can take any two ray diagrams to showing the what image position. And the third case is, and our third position is object at C. If you are placing object at C, let's see, object at C, center of curvature. Exactly, we are placing object on center of curvature. So draw the ray diagram for pole, focus and center. Now we are placing object on C. Object on C. Now take one instant ray is parallel to the principal axis. One instant ray is coming from tip of the object. It is parallel to the principal axis and passing from focus. Passing from focus. And the second ray is passing from focus. Second ray is passing from focus. And we know that reflection is parallel to the principal axis. Reflection is parallel to the principal axis. Here the two reflected rays are intersected. We know that two reflected rays are intersected. That is our image point. Here the image is formed. Image is formed exactly at C only. Image is formed exactly at C only. That means if you are placing object at C, image also forms at C. Let's write image formed at C. Object placing at C, image also forms at C only. Write the characteristics. So which type of image it is? It's exactly real image. Already it is forming on screen. So real image, it's a real image inverted, real image inverted, and same size image, and same size image. So only in this one case we'll get the what equal size of image and the object size and image size are similar when we are placing object on center of curvature. Let's move to the fourth position. What is our fourth position after C? So next possibility is between F and C. Now place the object between F and C. Object between F and C. We are placing object between F and C. Let's draw the concave mirror. Pole, focus and center. Now object between F and C. Place object between F and C. Consider two ray diagrams. The first ray diagram is parallel to the principal axis. I am always taking first ray is parallel to the principal axis, not exactly mandatory, that is your wish. We are having 4 ray diagrams. From that you can take any 2 ray diagrams for showing image position on concave wall as well as convex mirror. So I am taking first ray is parallel to the principal axis and this ray is passing from focus. If instant ray is parallel to the principal axis, we know that reflection is taking place from focus. And the second ray is moving from, second instant ray is moving from focal point, and after reflection we know that it is parallel to the principal axis. Here the intersection is done. The two rays are intersected here. So that is exactly beyond C. So in fourth case, if you are placing object between F and C, image formed beyond C, image formed beyond C, and this fourth case is opposite to the what? Second case. In second case, where we have placed object beyond C, we are object placed between F and C, image is formed. In this fourth case, we have placed object between F and C, image formed beyond C. It is looking like bigger. So here image size is what? Bigger, I mean bigger than object size. So let's write where image is formed. Image formed beyond C. Image formed beyond C. After C, image is formed. Next character, it's a real image, inverted image, real image and inverted image. It is bigger than object size. Already we have discussed, if image size is bigger than object size, that image is called as magnified image or enlarged image. If maybe size of image is lesser than object size, that is diminished image. Let's write it's enlarged image, enlarged or magnified image. So only in this one case we'll get the what? Magnified real image, magnified real image. Next position is object at F. So just now we have completed object between F and C, image formed beyond C. And the fifth case is, fifth position is object placing at F. Object at, if you are placing object at focus, what happens? Let's see. So concave mirror, first draw the concave mirror. Pole, focus and center. Now where we are placing object? On F. Now the first instant ray is, I am taking parallel to the principal axis, the ray is coming like parallel to the principal axis and passing from focus. And the second ray is moving from the second ray is moving from center of curvature. We know that reflection also taking place from center of curvature. In this case, we are not seeing any intersection. So last 4 positions we have seen intersection of reflecting rays, and we are considered that intersecting point is image point, but there is no intersecting point here. That means image formed at infinity. Image formed at infinity. So while doing this experimentation, I mean you are doing as a practical, and that time we'll get the image on screen. It's look like a what? Highly enlarged. It's look like a what? A highly enlarged image. But in textbooks they were not mentioned about what is the characteristics of image here. Just they are mentioned image formed at infinity. But actually you are doing that as a practical, you are doing directly, and that time you will get the word image on screen, but infinity of distance, it's enlarged mode. So let's write image formed at infinity. See here, when we are placing object at infinity, that case image is formed at f. But now object only placed at f, image forming at infinity. This is opposite for first case. This is opposite for what? First case. So write the characteristics: real, inverted, highly enlarged image, highly enlarged, and this should will get while doing as a practical. You are doing that experimentation lively, and that time will get this. So but actually the image is formed at infinity. If you are placing object at f, image forms at infinity. And our last position is, that is our 6th position, last possibility also, the object placing between p and f. Object between p and f. Object between p and f. Let's draw the concave mirror here. E, F and C. Now place object between P and F. I am placing object here. So now consider one ray is parallel to the principal axis passing from focus, and the second ray is also passing from center of curvature, reflection also done from center of curvature. Now these two reflected rays are, if you are extending back, I mean here the image is not going to form on screen. The image appears inside the mirror. We know that that is a virtual image. So where images appears in the mirror, that image is called as, which images appears in the mirror, that image is called as virtual image. So in this case, only in this one case, virtual image can appears inside the water concave mirror, and that's what concave mirror can shows two types of images here, virtual image as well as real images. So here the image is formed, it's enlarged and virtual, If you are placing object between P and F, draw the ray diagrams like that. If you are extending the two rays into behind the mirror, and that time where the two rays are intersected, we can consider that intersecting point as image. It's an enlarged image. Let's see image formed behind the mirror. Image formed behind the mirror. Characteristics. So this is a virtual image. It's a virtual image and erected. Virtual image erected and high and magnified image. So these are the 6 positions for concave mirror. So once again I am repeating these 6 types of positions on concave mirror. First position is object placed at infinity. Image forms at focus. That is a point size image. And the second case is if object placed beyond C. beyond C, the image forms between F and C. The image forms between F and C, that is real image, inverted image and a diminished image, small image, it's a diminished image. And the next position is, if you are placing object at center of curvature, if you are placing object at a center of curvature, image also forms at center of curvature. Image also forms at center of curvature. It's a same size image. Remember, this case is very important in examination pattern. So image also same size, it's a real and a inverted. And the next case is, if you are placing object between P and F, if you are placing object at a, sorry, not P and F, object between F and C, object between F and C. So if you are placing object between F and C, image forms beyond C. Image forms beyond C. It's a real image, inverted image, enlarged image. And the next case is, if you are placing object at F. If you are placing object at F, in this case, image forms at infinity. If you are doing that experiment, by using concave mirror, and that case you will get the what exact characteristics of image, that is highly enlarged and inverted real image. And the next case is, if you are placing object between P and F, if you are placing object between P and F, in this only one case we will get the what virtual image. The image forms behind the mirror, it's a erected image and a magnified image. Virtual, erected and a magnified image. This is about image positions for concave mirror. And what about image positions for convex mirror? But convex mirror is a diverging mirror. If you are placing object anywhere in front of convex mirror, we'll get the what only one type of image. But concave mirror is not like that. So in different positions we'll get the what different position of images. But convex mirror is not like that. If you're placing object in front of convex mirror, if you're not exactly based on distance or based on position like concave mirror, we can't able to take the positions. I mean couple of positions are not possible. Why? Because only one type of image. If you're placing object anywhere in front of convex mirror, we'll get virtual diminished image. Virtual diminished image. If you're placing object any distance in front of convex mirror, we'll get the what only similar image. That is why convex mirrors are used as rear view mirrors in vehicles. It's a very important in 2 marks. So which mirrors are used in rear view mirrors in vehicles? So nothing but convex mirrors are used as rear view mirrors in vehicles. Why? Because it forms only one type of image, only similar image, that is virtual diminished image. And we are having experience while we are observing images on bike rear view mirrors or car rear view mirrors, which vehicles are coming from backside. So these are appears small size to us. We are able to saw that image is very small in size and virtual image. Actually that is not plane mirror, it's a convex mirror. Let's see one example for image position on convex mirror. You can draw that position only if in examination the question comes, draw the image position for convex mirror. You can draw that image positions. Enough, that is very enough to us. So image position for convex mirror, already told you. So only one image position is enough to us. Let's draw the what is the image position for convex mirror. Draw the convex mirror first. So once again I am telling you, this coating is very important. So you don't cut, very important. Start. Coating is very important. Pole, focus and center. I told you convex mirror can show virtual images. Now imagine one object is placed in front of convex mirror, So take one ray as parallel to the principal axis and reflected back. Already I told you ray diagrams. If you are extending these reflected ray into inside the mirror, it is passing from where? Focus. And next take one more ray, draw the one more ray, maybe it is strikes at P. Instant ray falls on P, it is reflected back from P only. Now extend these reflected ray into inside, where these two reflected rays are intersected inside the mirror, here the image is formed. This is virtual image. This is virtual image and diminished image. Size also what? Small. So diminished virtual image possible on convex mirror. If you are placing anywhere, there is no exactly a proper distance. You can place any distance, will get the what? Only one type of image, like what? Real, virtual and diminished image. And the next class we are going to discuss about mirror formula, derivation of mirror formula, as well as magnification and related problems. Thank you.